Okay, we're going to look at a related rates problem involving a trig expression. We have a fish is reeled in at a rate of 1 foot per second from a point 10 feet above the water. So notice that's telling us that since this is the fishing pole and this is the line, that's telling us that x is changing at a rate of change of 1 foot per second. And we're asked to find at what rate this angle between the line and the water is changing when there is a total of 25 feet of line out. So since this is the end of the fishing pole, that means x at 25. Okay, so notice that we do have a right triangle here. So we can use our trig ratios, and we see that we get that sine of theta equals 10 over x. So my two variables are x and theta. I now need to differentiate this with respect to t. In order to do that, most of you would probably prefer to see this as written as 10x to the negative 1. So now let's differentiate. Remember, when I differentiate with respect to time, the derivative of sine of theta will be cosine of theta, but then I have to remember to multiply by d theta dt. That's chain rule there. Over here, when I take the derivative, I get negative 10x to the negative 2, and again I have to multiply by dx dt because of chain rule. So now I have to fill in all the values that I know. Note that they didn't tell me what theta is when there's 25 feet of line out, but we can figure that out using a trig ratio. Okay, so I did the workout on the side. When x is 25, we can solve for theta, and we get 0.4115, and this is in radians. So now I substitute in what I know into my equation. And note that when I plug everything in, my dx dt is negative 1 because the fishing line is being reeled in at a rate of 1 foot per second. So that line is going to get shorter at a rate of 1 foot per second. So everything else I've just plugged in for. And now let me simplify. And now we solve for d theta dt and get 0.017457 radians per second. And remember that you have to work in terms of radians per second instead of degrees, because once you took the derivative of sine and said that that was cosine, that is using the fact that we're in radians. Otherwise, if it was in degrees, you would have to use chain rule and multiply by some constant multiplier. So when you're working with derivatives and trig, make sure to work in radians.